Hello everyone. Today we will study the topic of gears. Gears are tooth members which transmit power or motion between two shafts by meshing without any slip. Hence, gear drives are also called positive drives. In any pair of gears, the smaller one is called pinion and the larger one is called gear, immaterial of which is driving the others. When pinion is the driver, it results in step-down drive in which the output speed decreases and the torque increases. Whereas when the gear is the driver, it results in step-up drive in which the output speed increases and the torque decreases. Speed ratio or gear ratio. Speed ratio or gear ratio is the ratio of pinion speed to gear speed, the equation for which will be given over here. Types of gears. Gears are classified according to the shape of the tooth pair and disposition into spur, helical, double helical, bevel, worm and spiral gears. For classification of gears, following arrangements of transmission shafts are considered. Number 1. Parallel axis gears. Number 2. Intersecting axis gears. Number 3. Non-intersecting and perpendicular axis gears. And number 4. Non-intersecting and non-parallel axis gears. These gears are discussed step by step. First, parallel axis gears. Two parallel axis shafts can be connected by the following three types of gears: spur gears, helical gears and herringbone gears. Spur gears are shown over here, where larger diameter teeth wheel is known as spur or gear and smaller diameter teeth wheel is known as spur pinion. Spur gears have their teeth parallel to the axis and they are used for transmitting power between two parallel shafts. They are simple in construction, easy to manufacture and costless. They have highest efficiency and excellent precision rating. They are used in high speed and high load applications in all type of trains and a wide range of velocity ratios. Hence, they find wide applications right from clocks, household gadgets, motorcycles, automobiles and railways to aircrafts. They can be used for reduction ratio up to 6:1. Helical gears. Helical gears are used for parallel shaft drives. They have teeth inclined to the axis, hence for the same width their teeth are longer than spur gears and have a higher load carrying capacity. Their contact ratio is higher than spur gears and they operate smoother and quieter than spur gears. Their precision rating is good. They are recommended for very high speeds and loads. Thus, these gears find wide applications in automotive gearboxes. Their efficiency is slightly lower than spur gears. The helix angles of gear and pinion are same in magnitude but opposite in hands. Also introduces axial thrust on the shafts. Herringbone gears. In order to avoid an axial thrust on the shafts, the double helical gears or herringbone gears are used. Double helical or herringbone gears used for transmitting power between two parallel shafts. They have opposing helical teeth with or without a gap depending on the manufacturing method adopted. Two axial thrusts opposes each other and nullify. Hence, the shafts is free from any axial force. Though their load capacity is very high, manufacturing difficulties makes them costlier than single helical gears. Their applications are limited to high capacity reduction drives like that of cement mills and crushers. External gear pair. Two gears mesh connected externally. The pinion and gear always rotate in opposite direction. Applications used in automobile machine gearboxes and watches. Internal gear pair. An internal gear meshes with an external pinion. The pinion and gear always rotate in same direction. It is very compact as compared to external gear pair. Applications of these gears can be seen in planetary gear drives of automobile automatic transmissions. We can see in this diagram the internal gear meshes with the external pinion. Both of them are rotating in same direction. Internal rack and pinion. Rack is a segment of a gear of infinite diameter. The tooth can be spur or helical. This type of gearing is used for converting rotary motion into translatory motion or vice versa. Typical example of rack and pinion applications are: they are used in machine tools like lathe, drilling machine and milling machine. The rack and pinion gears are shown in the diagram over here. Intersecting axis gears. Straight bevel gears are used for transmitting power between intersecting shafts. The pitch surface of the bevel gears is frustum of cone. The size of bevel gear decreases towards the apex. They can operate under high speed and high loads. Their precision rating is fair to good. They are suitable for 1:1 and higher velocity ratios, and for right angle meshes to any other angles. Their good choice is for right angle drives of particularly low ratios. However, complicated form and fabrication limits the achievement of precision. They should be located at one of the less critical meshes of the train. Wide applications of the straight bevel gears is in automotive differentials, right angle drives of blenders and conveyors. The bevel gear arrangement is shown in the diagram over here. Non-intersecting and perpendicular axis gears. Worm and worm gear pair consist of a worm, which is very similar to a screw, and a worm gear, which is a helical gear. They are used in right angle skew shafts. In these gears, the engagement occurs without any shock. The sliding action prevalent in the system, while resulting in quieter operations, produces considerable frictional heat. High reduction ratios 8 to 400 are possible. Efficiency of these gears is low, anywhere from 90% to 40%. Higher speed ratio gears are non-reversible. Their precision rating is fair to good. They need good lubrication for heat dissipation and for improving the efficiency. The drives are very compact. Non-intersecting and non-parallel axis gears. Spiral gears are also known as cross helical gears. They have high helix angle and transmit power between two non-intersecting non-parallel shafts. They have initially point contact under the conditions of considerable sliding velocities. Finally, gears will have line contact. Hence, they are used for light load and low speed applications such as instruments, saving machines, etc. The precision rating is poor.